Hi guys, and welcome to another video. In today's video lesson, we're going to be continuing with grade 11 maths trigonometry, trigonometric identities, and the reduction formula. But the paper that we're going to be focusing on is the November 2018 paper 2, and it is question 5, and it reads as follows. It says here in the diagram below, t, x, and 15 is a point in the Cartesian plane such that OT is equal to 17 units. And here they tell us that P is minus 2 and a lies on the line OT, K is a point on the positive x-axis, and TOK is theta. Theta is our reference angle here. So let's have a look at our diagram. Now the important thing for us to take note of here is that when the diagram is given, then we need to drop down a perpendicular that is to the x-axis and complete that particular triangle. Now sometimes they may just give us a particular condition, like in this particular example they'll tell us, like for example, that theta lies between 0 and 180 degrees, and maybe they'll tell us sine is positive, all right, or maybe they'll tell us cos is negative. Okay, so we need to be able to say, okay, cos is negative in the second quadrant, and we got right, so it can't be the first quadrant because in the first quadrant all the trig ratios are positive. So that's right. So that goes back to learning your cast diagram, and I did the cast diagram in part 1 of this particular video, and I'll just write it over here very quickly for you, or draw it rather. So that will be y and x. Remember the cast diagrams as follows. That's quadrant 1, quadrant 2, quadrant 3, quadrant 4, and it goes as follows: all sine, tan, and cos. All trig ratios positive in the first quadrant, only sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. And we need to know our formulas. Now let's go back to the question. So if you look here, t is x and 15. So x, don't forget, in the second quadrant, x is negative, y value is positive, so that's 15, like so. And they already told us that OT is 17 units. There's it here. So they're giving us the hypotenuse or the R value, radius. Okay, so determine with the aid of a diagram the following, the value of x. So we have to use the theorem of Pythagoras here. But don't forget, x is negative in the second quadrant, so 5.1.1. We're going to say x squared is equal to the hypotenuse squared minus the other side squared. So that will be 17 squared minus, what we got here, 15 squared. 15 squared, and we are using the theorem of Pythagoras. So that will be 17 squared. 17 squared minus 15 squared. That's 64. 64. Therefore, let's conclude x is going to be plus minus the square root of 64, which is going to be negative 8. So x is equal to negative 8, because remember now, and I'm just going to write this for your knowledge here, because remember in the second quadrant x is less than 0. Now you don't have to write that in the exam, you just need to write down the correct value for x here, which is x equals to negative 8. So let's go and fill that in on the diagram. It's important. Now in the negative 5.1.2, what is tan of theta? Tan of theta is equal to the y value over the x value. So y over x, or opposite over the adjacent. Remember, so y over x. Remember, y is your opposite side, x is your adjacent side. So what's your y value? Your y value is 15 and your x value is minus 8. So that will be 15 over minus 8. So let's write that down. 5.1.2. Tan of theta equals to 15 over minus 8. So that will be 15 over minus 8. 5.1.3, cos of 180 minus theta. Now this goes back to the reduction formula. So let's go back. Remember, 180 minus theta is discussed in the previous video, part 1. 180 minus theta is the formula for the second quadrant, and remember that only sine is positive in the second quadrant. So therefore we can look at this and say, well, cos of 180 minus theta will reduce to minus cos of theta. Now 5.1.3. We will write down cos of 180 minus theta, so we can just write the reduction, which is minus cos of theta, which will equals to x over r, which will be minus 8 over 17 x over r. So that will be minus 8 over 17, which is equal to minus times minus is plus, and that will be 8 over 17. Final answer 5.1.4. In this question they want the sine squared of theta. So sine squared of theta. So 5.1.4. Remember that sine is, what is sine? Sine is y over r, opposite over hypotenuse, and we're going to square that, right? So let's substitute our y and our r values. So my y value is 15, r value is 17. So let's put 15 over 17 all squared, sine squared of theta. So let's go put that in the calculator. So here we got 15 over 17 squared equals 225 over 289. 225 over 289. Now calculate the value of a. So now they want us to find the value of a. So let's look at here. What is this? P is minus 2 and a. So you have to drop down the perpendicular there. Remember that the x value is minus 2 and the y value is a. So that's your x and that's your y value. So you're given the x and the y value. Now which ratio can you use in terms of x and y only? We don't have r, okay? So therefore, I can use tan of theta because the angle is the same. But I already found tan of theta. Tan of theta was in 5.1.2. We already found it. And tan of theta was, there's our answer here, will be 15 over minus 8 or minus 15 over 8, right? So basically tan of theta is 15 over minus 8. But here we know that y over x, so we can say y over x. So that will be a over negative 2 will equals to 15 over minus 8. Therefore, a will equal to minus 2 times 15 minus 2 times 15 over minus 8. And what will we get there? So let's go and check that out. So that will be minus 2 times 15 all over minus 8. It's 15 over 4. 15 over 4. So this one here now, I'm going to leave the answer there, right? So that will be 5.1.5. So 5.1.5, you can go and write it down neatly, right? So A will be 15 over 4. Let's go look at the next question. And I'm going to end the video with this particular question here because in the next series of videos, I'll be looking at identities and trig equations. So let's look at simplify without using a calculator. So once again, reduction formulas here. Sine of 120, we have to use our reduction formula. Where does 120 lie? Remember that 120 lies here. 0, 90, 180, 270, and we come all the way back to 360. So 120 lies in the second quadrant. So that means we have to use the formula 180 minus theta. And remember, special angles are what we will be using. What are special angles? Well, special angles is 0, 30, 45, 60, and 90. All right. So the most common ones obviously would be 30, 45, and 60 degrees. So let's continue then. So 180 minus 1 will give me 120. Say 180 minus. So you have to use the formula first of all. What's the formula? 180 minus theta. Why? Because remember it's in the second quadrant, which is going to be 180 minus 60 degrees. So basically I'm going to be left with sine of 180 minus 60 degrees, which is equal to, second quadrant sine is positive, so that's going to be sine of 60 degrees, and sine of 60 is a special angle, give us a root 3 over 2. Okay, so firstly now let's go write down the first step there. The first step that I want us to write down there is this. We only need to write that in our answer. So sine of 60, and Then we'll come back and later we'll put that root 3 over 2 and so on. So let's write that down. 5.2. So 5.2. So the first thing you must say now is you can do this working on your own. Sine of 180 minus 60. But where the mark allocation will be is here, sine of 60 degrees. Right? So you must write down sine of 60. So we're going to say sine of 60 degrees times. Let's go work out the rest in the same way. See 210 degrees. It lies here in the third quadrant. What's the formula for the third quadrant? 180 plus theta. Right? So 180 plus what will give you 210? 180 plus 30. Okay, it's another special angle. So let's go write that down. So therefore now for 210 will be cos of 180 plus 30. Now remember that in the third quadrant, tan is positive, which means cos is going to be negative. So that's going to be minus cos of 30 degrees. Cos of 30 degrees is a special angle. It will be root 3 over 2. So you should get minus root 3 over 2. You can check all of these using your calculator as well. Alright, so what we're going to write down? Well, we'll just write down this minus cos 30 for now. And so we'll write down minus cos 30 degrees like so. Let's continue. Now you got 315. Where does 315 lie? 315. There's it here. It lies in the fourth quadrant. What's the formula for the fourth quadrant? 360 minus theta. So 360 minus what will give you 315 degrees. So if you have to look at that now, maybe 315, there's it here. Right? So you're going to say 360 minus 45. So it'll be tan of 360 minus 45. And remember now, in the fourth quadrant, only cos is positive. So therefore, what is this going to reduce to? It will be minus tan 45. So then I'm just going to write down minus tan 45. Minus tan of 45 degrees there. Okay. Now, cos of 27 degrees. Now, 27 is an acute angle. I can't reduce it any further than that. Okay, so there's a big chance here that they are testing complementary angles. Okay, so let's continue and I'll show you what complementary angles is all about. So I'm going to write down cos of 27 degrees and leave it as that for now. So I'm going to say cos of 27 degrees all over. Let's continue here. Sine of 63, there we go. See, if you add 63 plus 27, you'll get 90 degrees. What does this mean for us? It means that cos of 27 degrees is equal to sine of 63 degrees. And that comes from knowing our ratios, right? And our ratios are, remember, sine of 90 minus theta equals to cos of theta, cos of 90 minus theta equals to sine of theta. Complements of each other. So therefore, let's just change sine of 63 to cos of 27 and cancel them off. So we'll write cos of 27 down here at the bottom, cos of 27 degrees. And over here now, 540. Remember what I told you in the previous video, if you watched part 1, whenever you have an angle greater than 360, you must just subtract multiples of 360. So you'll say 540 minus 360. So you'll carry on subtracting multiples of 360 until you get an angle which is between 0 and 360. So here we got 180 degrees. So we'll write cos of 180. So therefore this becomes cos of 180 degrees, which is equal to, now we can just cancel this, cos of 27 and cos of 27. Sine of 60 is root 3 over 2. Cos of 30 or minus cos 30 is minus root 3 over 2. Minus tan 45, remember tan of 45 is 1, so that's going to be minus 1. And the cos of 180. Now remember, right, because 180 is on a borderline here, right, you can reduce it using this here. You can say 180 minus 0 or 180 plus 0. In both cases, remember, in the second and the third quadrant here, cos is both negative. So you're going to get minus cos of 0, right? And cos of 0 is equal to 1. So minus cos of 0 should give you minus 1. Minus cos of 0 equals to minus 1. So I think it's just good enough there for us to just write down negative 1 minus 1 like so. Equals to. So now if you look at it, see minus 1 and minus 1 will cancel. Root 3 times root 3 is 3. Plus times a minus is minus, and 2 times 2 is equal to 4. That is, I'm going to leave it there in this video. If you haven't subscribed, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.